My name is Engineer Ejike Patrick. I'm here to present to you a paper titled Determination of some General Properties of African Walnut relevant to int processing as affected by moisture content and dry method on Sustainable Engineering and Industrial Technology Conference of Faculty of Engineering, University of Nigeria, Nsukka, on 6 to 11 June 2020. African walnut is a perennial climbing shrub which grows mainly in the western region of Africa. It is widely distributed in the south part of Nigeria and locally called Okpa in Igbo, Hausa and Isala in Yoruba, and Igbo in Efik and Bibian. In Nigeria, the African walnut is basically processed by boiling in water or roasting in hot sand before consumption as a snack. Problem statement: as a result of increasing interest in the use of African walnuts for medicine as soup thickener, food and other various purposes, especially new product development, there's a need to properly explore the benefits of this important agro material. Apart from that, agricultural material has to be harvested, handled, packaged, stored, processed into other bio products. These processes require good knowledge of mechanical properties, and the data that will be generated from this research will enable the efficient design of equipment of machine for int handling, storage, further processing for value added. Collection and preparation of the sample. The African walnut sample used for this research work were sourced from Enugu State Polytechnic, crop unit, Iwolo, Enugu State. The sample were cleaned and graded by hand picking to remove dirt and to select a viable seed. And after that, the samples were conditioned at 3 different moisture content levels, which is 12%, 50%, and 18% dry base, at which the test experiments were conducted. The samples were preserved at the conditioned moisture content by storing them in airtight polythene bags in plastic container to avoid gain or loss of moisture by natural method, and later moved to a laboratory where the properties were determined. This is the pictorial of big size walnuts, Enugu, and small size walnuts, Ntakri, because our research is based on variety, 2 varieties, which is the big size walnut and small size walnut. These are the equipment that the researcher used to determine the mechanical properties. We have an caliper, we have multi-purpose oven, we have electrical digital weighing balance machine, and we have INSTRON Universal Testing Machine with Brew model series 3345. Mechanical property determination. This is the method used to determine the compressive strength. This is the method used to determine stiffness and toughness of the sample. This is the method used to determine the formation energy of the sample. This table 1 shows the mechanical properties of big size okpo seed, oven and sun dried at different moisture content and position. Table 2 shows the mechanical properties of small size okpa seed, oven and sun dried at different loading position. These are the graphs generated using the Universal Testing Machine. By looking at these graphs, you're able to know the trend and what happened inside the seed sample during compression. By looking at it, you see the trend with dark red color, which is small African walnut oven dry loaded at the vertical loading position, displays and recorded the highest cracking force, followed by small size walnuts sun dried loaded at the horizontal loading position. Then the third were big oven dry walnuts loaded at the vertical loading position. The list of the sample under 18% moisture content that requires lowest force to be cracked is the big sun dried African walnut at horizontal loading position. What does it imply? It implies that the small size of oven dried African walnut requires the highest force to be cracked, but the least sample that requires least force to be cracked is big sun dried African walnut at horizontal loading position under 18% moisture content. And this is exactly what happened to all these graphs down there. These graphs have the similar explanation to what I've explained in the previous graph, just that you can see that the sample that requires the highest loading, the highest cracking force varied at different conditions, at 18% moisture content, 15% moisture content, and 12% moisture content, considering the sizes and the variety. Now, exactly the same thing I explained there, just that looking at this graph, you see that the big size oven dry recorded the highest cracking force, while the sun dry big African walnuts recorded the least cracking force. Coming to this figure 8, figure 8 shows that the oven dry the big African walnut recorded the highest force, while that of the sun dry big recorded the least force. Similar thing happens to this graph. A similar thing happened to this graph, which is figure 11 and figure 12. This is the result of mechanical properties of African walnut. You see, from table 1 and 2 shows the range of compressive force of Enugu and Nsukka at the vertical loading position. Then it was observed that compressive force value were found to be higher at the vertical loading position for both samples tested. The result also shows that the moisture content variation varied the compressive force tested parabolically. And looking at this from table 1 and 2, the compressive strength of Enugu and Nsukka were recorded as follows, and this implies that the strength of African walnut was higher at the vertical loading position than that of horizontal loading position for both samples tested, and this may be as a result of the smaller contacts that occurred during the loading of the sample at the vertical position. Moisture content varied compressive strength tested across the whole sample. From table 1 and 2 also, compressive extension recorded at horizontal loading position are shown below. It was observed that the moisture content increase, the compressive extension showed progressive increase when the sample is in horizontal position. For both sample at vertical loading position, the compressive extension with moisture content variation display parabolic trend for both sample. It implies as the sample moisture content increase, the sample becomes more elastic than brittle, thereby causing the long compressive extension. Elongation were found to be higher when the sample is loaded at horizontal loading position. The mechanical properties continue from table 1 and 2. The formation energy recorded at horizontal loading position are shown below. It was observed that the increase in moisture content of the sample increased the total energy that will cause rupture on the sample. It was noticed that the deformation energy of the Nsukka on the both loading position was higher than the Enugu, and this implies that Nsukka is stronger at each of the loading position. But for both sample, the formation energy were found to be higher at every vertical loading position. Now, mechanical properties result continue. The result of mechanical properties of African walnuts were found to be moisture content dependent, from 12% to 18% dry base. The relationship that existed between the moisture content and the mechanical properties were statistically significant and 0.5% level. The maximum load ranges from 384.19 Newton to 137.80 Newton and 410.34 Newton to 159.1 Newton at horizontal loading position and vertical loading position respectively for Enugu. For Nsukka, the maximum load ranges from 175.91 Newton to 70.110 Newton and 246.40 Newton to 46.21 Newton at horizontal and vertical loading position respectively, with increase in moisture content. Recommendation. It is recommended that other engineering properties that have not been studied on this sample, like aerodynamics properties, electrical, optical, acoustic, and sensory properties of African walnut, should be investigated in order to generate data for researchers and for the unit operation of the sample. It is recommended that also that the commercialization and small-scale production of food thickeners from African walnut flour could be encouraged through the training in entrepreneurship center. It is also recommended that the awareness and sensitization of members of the public on the potentials of African walnut should be encouraged through the media symposium, conferences, and seminars. Thank you, and God bless you for listening.